Maths Solutions by Pani. Here in this video we are discussing about exercise 5C, differentiation. In differentiation also implicit function of differentiation and inverse function, trigonometric inverse differentiation. We are going to do that. Okay, dear students, let us discuss the questions. In exercise 5C, find the value of dy by dx for the following functions. The first function is 2x plus 3y is equal to sin x. So for this type of functions, we need to differentiate. See, differentiate with respect to x. So, two constant bring outside d by dx of x plus 3 constant bring outside d by dx of y is equal to d by dx of sin x. So 2 into d by dx of x is 1 plus 3 into d by dx of y is dy by dx is equal to d by dx of sin x is cos x. Except dy by dx remaining all bring that side. 3 into dy by dx is equal to cos x minus 2. But I want dy by dx, no. So that implies dy by dx is equal to cos x minus 2 divided by 3. This is the differentiation of the given implicit function, dear students. Question number 2. 2x plus 3y is equal to sin y. Here observe carefully, dear students. The question little difference. So here also differentiate with respect to x. So 2 into d by dx of x plus 3 into d by dx of y plus d by dx of sin y. So 2 into d by dx of x is 1 plus 3 into d by y dx. Here d by dx of sin y, the function in terms of y, we are doing differentiation with respect to x. So sin y derivative is cos y. First you write it, dear students. Later this y value again you have to differentiate with respect to x. D by dx of y. So 2 into 1 is 2 plus 3 into dy by dx is equal to cos y into dy by dx. dy by dx of y is dy by dx. All the dy by dx terms bring one side. So 2 equal to this 3 value bring this side. Cos y into dy by dx minus 3 into dy by dx. Take common. 2 equal to cos y minus 3 into dy by dx. dy by dx make subject and get it. So 2 by cos y minus 3 is equal to dy by dx. Okay, dear students, I hope you understand. This is the way you have to differentiate the implicit functions. Okay. Now we'll move to question number 3, dear students. So question number 3 is ax plus by square is equal to cos y. See, whatever the method we followed, that only we can do it. So differentiate with respect to x. So constant into function is there, constant bring outside, and the rest of the function you have to differentiate. D by dx of x plus b into d by dx of y square is equal to d by dx of cos y. So a into d by dx of x is 1 plus b into d by dx of y square. It is looking like d by dx of x square. No? So, but function is y square. With respect to x, we are differentiating. D by dx of y square is 2y. Again, this y differentiate with respect to x. dy by dx is equal to d by dx of cos y. Function is in terms of y. We are differentiating with respect to x. What is d by dx of cos y? Minus sin y. Again, this y value with respect to x we have to differentiate. D by dx of y. So a into 1 a plus 2by into dy by dx is equal to minus sin y into dy by dx. So this dy by dx bring the side. So a equal to minus 2by into dy by dx minus y into dy by dx. So from these two, dy by dx take out common. A equal to minus 2by minus sin y into dy by dx. Dy by dx makes subject. So that implies that dy by dx is equal to a by minus 2by minus sin y. So minus you take out common. Therefore, dy by dx equal to this minus, if we take out common from these two and write in the numerator, minus a by 2by plus sin y. Okay, dear students, I hope you understand. So the final answer is minus a by 2by plus sin y. Next, we'll move to question number 4. What is the question number 4? xy plus y square is equal to tan x plus y. A similar method you have to follow what we did in the previous questions. So differentiate with respect to x. So d by dx of xy plus d by dx of y square is equal to d by dx of tan x plus d by dx of y. So here d by dx of xy, with respect to x we are differentiating the product of two functions which are involving in x and y. So you can take it as u into v, product rule of differentiation. Here you have to apply. So that implies that first x treating as u and d by dx of y plus y treating is v into d by dx of x plus d by dx of y square like previous problem So d by dx of y square is 2y. Again y derivative with respect to x. D by dx of y is equal to d by dx of tan x secant square x plus dy by dx. Now the terms containing dy by dx. Before that we will simplify. X into dy by dx plus y into d by dx of x is 1 plus 2y into dy by dx is equal to secant square x plus dy by dx. All the dy by dx terms bring one side and other terms like variables bring another side. So plus 2y into dy by dx minus dy by dx is equal to secant square x minus y. This y value we are bringing this side. So from all the terms in LHS, we are taking common dy by dx. X plus 2y minus 1 is equal to secant square x minus y. But I want dy by dx now. So dy by dx is equal to secant square x minus y divided by x plus 2y minus 1. Therefore, dy by dx is equal to secant square x minus y divided by x plus 2y minus 1. This is the final answer, dear students. I hope you understand. Now we'll move to like 8 questions are there. We'll do that all the questions. Nothing will happen. We'll do slowly. Yeah, please respond whether it is you're able to catch these points or not. Please. Question number 5. The function is x square plus xy plus y square is equal to 100. So implicit function differentiation. Differentiate with respect to x. D by dx of x square. See, this is the way you write it. Plus d by dx of xy plus d by dx of y square is equal to d by dx of 100. Later, d by dx of x square, 2x, d by dx of x power n into x power n minus 1. Plus here, in the previous problem also we applied u into v, product rule of differentiation we are applying. X into d by dx of y plus y into d by dx of x plus d by dx of y square, that is y square derivative is 2y, again y derivative is dy by dx, equal to d by dx of 100 constant is 0. So that implies that 2x plus x into dy by dx plus y into d by dx of x 1 plus 2y into dy by dx is equal to 0. The terms containing dy by dx except remaining all bring that side. So dy by dx, here x, here plus 2y is equal to these values we are bringing this side, minus 2x minus y. So that implies that dy by dx into x plus 2y is equal to minus take common 2x plus y. So dy by dx makes subject dy by dx equal to minus of 2x plus y whole divided by x plus 2y. This is the final answer for the question. Okay, dear students. Next, question number 6. X cube plus x square y plus xy square plus y cube is equal to 81. You try, dear students, and come back. Yeah, did you try, dear students? See here, like previous problem, differentiate with respect to x. D by dx of x cube plus d by dx of x square y plus d by dx of xy square plus d by dx of y cube is equal to d by dx of 81. See, d by dx of exponent formula, if you apply, you will get 3x square plus here u into v formula, dear students. This is u, this is v. So x square into d by dx of y plus y into d by dx of x square plus similarly even here also you can apply u into v. X into d by dx of y square plus y into y square into d by dx of x plus d by dx of y cube. D by dx of constant is 0. We'll write that step by step. 3x square plus x square into d by dx of y is dy by dx plus y into d by dx of x square 2x plus x into d by dx of y square is 2y. Again y derivative is dy by dx. Plus y square into d by dx of x is 1 plus d by dx of y cube is 3y square into again y derivative is dy by dx is equal to 0. The terms containing dy by dx, the terms not containing dy by dx, bring one side. So 3x square plus 2xy plus y square, 3x square, 2xy, y square. The rest of the terms containing dy by dx now. So dy by dx, x square plus 2xy plus 3y square is equal to 0. So later 3x square plus 2xy plus y square is equal to minus of dy by dx into x square plus 2xy plus 3y square. So from this what we have to do is we have to do it take dy by dx subject. So 3x square plus 2xy plus y square, even this minus will be here, by x square plus 2xy plus 3y square is equal to dy by dx. So this is the final answer for the given question. I hope you understand it, students. We'll move on to question number 7. So question number 7, sin square y plus cos xy is equal to k. So any idea, dear students? So differentiate with respect to x. dwrtx means differentiate with respect to x. So d by dx of sin square y plus d by dx of cos xy is equal to d by dx of k. It is in the form of f of x whole power n. So d by dx of sin square y means 2 into sin y. Again d by dx of sin y. d by dx of sin y. Whatever the function involved, d by dx of sin square y is 2 sin y. Again sin y derivative is cos y. Again y you have to differentiate dy by dx. Once again, d by dx of f of x whole power n is n into f of x whole power n minus 1. Again, this f of x you have to differentiate. Sin y derivative is cos y. Again, y also with respect to x derivative is dy by dx. Next, plus d by dx of cos x. d by dx of this is x in terms of x and y is there now. That we will do it. d by dx of cos x is minus sin x. Minus sin xy. Again this xy have to differentiate. d by dx of xy is equal to d by dx of constant is 0. Okay, dear students. Now 2 sin y cos y. What is 2 sin y cos y? Sin 2y. You have to aware of this formula. 2 sin a cos a is equal to sin 2a. Into dy by dx minus sin xy into key bracket d by dx of xy means uv formula, x into dy by dx plus y into d by dx of x is equal to 0. Sin 2y into dy by dx minus sin xy into x dy by dx minus y into sin xy, y into sin xy, d by dx of x is 1. Here actually before we need to this one, dy by dx this value is 1. So the terms containing dy by dx from these two, dy by dx, if we take out common, sin 2y minus x into sin xy. This value bring this side, y into sin of xy. So dy by dx makes subject. So dy by dx is equal to y into sin of xy divided by sin 2y minus x into sin xy. This is the final answer, dear students. This is the way we can do it. Question number 8. This is the last question in the first bit. This is completely bit 1. Sin square x plus cos square y is equal to 1. See how we are going to differentiate. So differentiate with respect to x. D by dx of sin square x, d by dx of cos square y is equal to d by dx of 1. Yeah, please like, dear students. Why? Because if you like this video, it reaches to more students. That is my sincere request to all viewers, those who are watching. So it is in the form of d by dx of f of x whole power n, means n into f of x whole power n minus 1. Again d by dx of f of x will come. So by using this formula, d by dx of sin square x means 2 into sin x. Again d by dx of sin x cos x, plus similar way d by dx of cos square y is 2 into cos y. Again d by dx of cos y is minus sin y. Again y derivative is dy by dx. See, once again I will tell by using this formula. D by dx of cos square y means 2 into cos y whole power 2 minus 1. Again d by dx of cos y is minus sin y. Again y derivative with respect to x is dy by dx is equal to dy by dx. D by dx of constant is 0. So later 2 take common. Sin x into cos x. Oh, better to write sin 2x. We already wrote the formula, no? I'm very sorry. Sin 2x minus into plus is minus. Again 2 sin y cos y is sin 2y into dy by dx is equal to 0. So sin 2x is equal to sin 2y dy by dx. But I want dy by dx. So make subject sin dy by dx. Sin 2x by sin 2y is equal to dy by dx. Therefore, the value of dy by dx equal to sin 2x by sin 2y. Now we will move to the question number second bit. We will start on a new page. These type of questions we may expect in the public exam, dear students. Surely, why, no doubt about it, this type of concept and very important. Second bit, find dy by dx. Find dy by dx in the following. So in that first question, y is equal to sin inverse of 2x by 1 plus x square. So to evaluate these type of functions in the differentiation, we have to know about the inverse trigonometry formula related. So here sin inverse of this one, this bracket value you have to bring into the form of sin theta. So for that put x is equal to tan theta. That implies that theta is equal to tan, bring this side, tan inverse x will come. Till here are you able to understand, students? Later y is equal to, substitute wherever x is there. Sir, how can we know that x is equal to tan theta only? Why can't other? So by proper substitution in place of x, you will get it idea whether it is any formula related to sine in terms of tan or tan in terms of tan. Like this, you will get it idea, dear students. So wherever x is there, you replace with tan theta. 2 tan theta divided by 1 plus tan square theta. We have the formula sine 2 theta in terms of tan. 2 tan theta divided by 1 plus tan square theta. So while solving this differentiation, especially implicit function and inverse trigonometric related functions, be careful, aware, and you have to know about all the formulas of differentiation, inverse trigonometry, and properties of inverse trigonometry functions as well. We already inverse trigonometry completed, dear students. Once you go to the channel and get it all the questions exercise wise, including MCQs. And you have to know about the properties, trigonometric formulas also. So which is equal to sine inverse. This bracket value can I write sine 2 theta. Again you have to apply the formula. Sine inverse of sine theta is equal to theta. So but in place of theta, what value is there? 2 theta is there. So y is equal to 2 into theta value is what? Tan inverse x. So from this is the complex form. By taking trigonometric functions, this function from complex form to simplex form we are doing, dear students. So that is the reason substitution method of differentiation is required. Differentiate with respect to x, dy by dx is equal to 2 constant bring outside a d by dx of tan inverse x. So which is equal to 2 into d by dx of tan inverse x is 1 by 1 plus x square. So dy by dx is equal to 2 by 1 plus x square. This is the final answer. Okay, dear students, we'll move to question number 2. Y equal to tan inverse of 3x minus x cube divided by 1 minus 3x square minus 1 by root 3 is less than x is less than 1 by root 3. Is a good question, dear students. Here also in substitution method, put x is equal to tan theta. Sir, why you are taking only tan theta? If I substitute in place of tan theta, that bracket value will get tan 3 theta formula. That implies that theta is equal to tan inverse of x. So which is equal to tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. So y is equal to tan inverse of, this bracket value is the formula for tan 3 theta, dear students. Here I will write it. Tan 3 theta is equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. So which is equal to tan inverse of tan 3 theta. Again we have formula inverse trigonometry. Tan inverse of tan theta is equal to theta. So here 3 theta will come. So y is equal to 3 into theta is what? Tan inverse x, no? So now differentiate with respect to x. So y derivative is dy by dx. 3 into d by dx of tan inverse x. What is d by dx of tan inverse x? 3 into 1 by 1 plus x square. Therefore, the value of dy by dx is equal to 3 by 1 plus x square. Okay, dear students, I hope you understand. We'll move on to the next question. Question number 3. Y is equal to cos inverse of 1 minus x square by 1 plus x square. 0 is less than x is less than 1. Even here also first you have to take the proper substitution. Put x is equal to tan theta. That implies theta is equal to tan inverse of x. So cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. You have the formula cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. This is the formula for cos 2 theta in terms of tan. So cos inverse of cos 2 theta. Again we have formula cos inverse of cos theta is equal to theta by using inverse trigonometry properties, dear students. Y is equal to cos inverse of cos 2 theta is theta. So y is equal to 2 into theta is tan inverse x only, no? Again, differentiate with respect to x. So y derivative is dy by dx equal to 2 into d by dx of tan inverse x. So 2 into d by dx of tan inverse x is 1 by 1 plus x square. Therefore, dy by dx equal to 2 by 1 plus x square. This is the final answer, dear students. Question number 4. Y is equal to sine inverse of 1 minus x square by 1 plus x square. Same method we have to follow, but the thing little change. See where we are going to change. Put x is equal to tan theta, this will be same. That implies theta is equal to tan inverse x. Later, 1 minus tan square theta by 1 plus tan square theta also will be same. That is the formula for cos 2 theta. Next, cos 2 theta in terms of tan sine pi by 2 minus 2 theta. That's what I want. So, sine inverse of 1 minus tan square theta by 1 plus tan square theta, dear students. So, sine inverse of this is cos 2 theta. Again, cos 2 theta we have to write in this form. Sine inverse of sine of pi by 2 minus 2 theta. Again, you have to replace the formula. Sine inverse of sine theta is equal to theta. So y is equal to sine inverse of sine pi by 2 minus 2 theta. So y is equal to pi by 2 minus 2 into theta value. What is theta here? Tan inverse x. So now differentiate with respect to x. Y derivative is dy by dx. D by dx of constant pi by 2 minus constant into function means d by dx of tan inverse of x. So dy by dx is equal to d by dx of constant is 0 minus 2 into d by dx of tan inverse x is 1 by 1 plus x square. So which is equal to minus 2 by 1 plus x square. Ultimately, the value dy by dx is equal to minus 2 by 1 plus x square. Okay, dear students, I hope you understand. We'll move on to the next question. More three questions are there. We'll finish it in this session maximum. I try my best. Question number is 5. Yes. Y is equal to cos inverse of 2x divided by 1 plus x square. Minus 1 is less than x is less than 1. So what we have to do, dear students? Even here also, put x is equal to tan theta. That implies theta is equal to tan inverse of x. So which is equal to cos inverse of 2 tan theta divided by 1 plus tan square theta. So cos inverse of, this is sin 2 theta. We already done. Sin 2 theta in terms of cos of pi by 2 minus 2 theta can we write? So cos inverse of pi by 2 minus 2 theta. So y is equal to cos inverse of, again you have to write inverse trigonometric property. Cos inverse of cos theta is equal to theta. So pi by 2 minus 2 theta. So y is equal to pi by 2 minus 2 into theta value tan inverse x. Now differentiate with respect to x. Y derivative is dy by dx equal to d by dx of pi by 2 minus 2 into d by dx of tan inverse x. So dy by dx, d by dx of constant is 0 minus d by dx of tan inverse x is 1 by 1 plus x square, which is equal to minus 2 by 1 plus x square. Therefore, dy by dx equal to minus 2 by 1 plus x square. Okay, dear students, we'll move to the other question. Question number 6. Y is equal to sine inverse of 2x into root of 1 minus x square minus 1 by root 2 is less than x is less than 1 by root 2. So here also put x is equal to, better to take sine theta, dear students. That implies theta equal to sine inverse x. Sir, in all the problems you have taken tan theta. Why you are taking here sine theta? If I take here sine theta, root of 1 minus sine square theta is cos theta, 2 sine theta cos theta sine 2 theta, sine inverse of this bracket value you have to get in terms of sine. That is the purpose we are taking, dear students. I hope you understand. So sine inverse of 2 into sine theta into root of 1 minus sine square theta, which is equal to sine inverse of 2 sine theta into root of 1 minus sine square theta is cos theta. So y is equal to sine inverse of 2 sine theta cos theta is sine 2 theta. Again, we have to apply the formula sine inverse of sine theta is equal to theta. So here according to that y is equal to 2 theta. So y is equal to 2 into what is theta we are assuming here? Sine inverse x. Now differentiate with respect to x, dear students. Y derivative is dy by dx. Constant into function is there. Constant bring outside. And the rest of the function you have to differentiate. D by dx of sine inverse x, which is equal to 2 into d by dx of sine inverse x is 1 by root of 1 minus x square. So your final answer is 2 by root 1 minus x square. Therefore, dy by dx is equal to 2 by root of 1 minus x square. Okay, dear students, I hope you understand. We'll move to the next question and last question in this session. Question number 7. What is that question number 7? If y is equal to secant inverse of 1 by 2x square minus 1, 0 is less than x is less than 1 by root 2. So here put x is equal to cos theta we are taking, dear students. Sir, why sir you are taking cos theta? Previously you have taken sin. See, theta is equal to cos inverse of x. Secant inverse of 1 by 2 cos square theta minus 1. You have the formula 2 cos square theta minus 1 is equal to cos 2 theta. Our aim is what? We need to bring this bracket value in respective trigonometric function. See, that is equal to secant inverse of 1 by 2 cos square theta minus 1 is cos 2 theta. The reciprocal of cos 2 theta is secant theta. Secant inverse of secant 2 theta. Secant inverse of secant 2 theta is 2 theta. So, y is equal to 2 into theta value is cos inverse of x. Differentiate with respect to x. Dy by dx is equal to 2 constant bring outside and d by dx of cos inverse of x. 2 into d by dx of cos inverse x minus 1 by root of 1 minus x square, which is equal to minus 2 by root of 1 minus x square. Therefore, dy by dx is equal to minus 2 by root of 1 minus x square. Okay, dear students, this is the final answer. I hope everyone understand. Till here, exercise 5C completed. In the next video, we'll discuss differentiation of the following functions. Just the normal differentiation like chain rule differentiation we will discuss in the next class. Thank you for your support. Jai Hind. Maths solutions by Pani. Those who are watching still, please like and share. If you like this video, it reaches to more students. Some people are watching but they did not like this video. Please, this is my sincere request from my side. Thank you all. Jai Hind. Maths solutions by Pani.